under 8.8, we're going to learn how to find the variance of a random variable. And the variance of x is usually written as, the variance of x is usually written as this, and it is found by the expected value of x squared minus ex itself, the whole of that thing squared. So this is like the mean of x squared and the mean of x then squared. And then, as you can see, we have been given a question that two fair cubical dice, that means there's six, it has 6 faces, it's a cube. Dice are thrown, one is red and one is blue. The random variable n represents a score on the red die minus the score on the blue die. We have been told that we have one red, this is red, and this is blue. And each one of them is having 1, 2, 3, 4, 5, 6 faces, numbered 1 to 6. Again, the red die has 1, 2, 3, all the way to 6 faces. What we have now in our sample space, or what we should have, for every value of red, you minus the corresponding value of the blue. For example, 1 minus 1, we have a 0. This is what we want to capture now. This is now that is explaining m. 1 minus 2, negative 1. 1 minus 3, minus 2, minus 3, minus 4, minus 5. When the red face is showing face 2 and the blue face, die is showing face 1, then 2 minus 1 is 1. 2 minus 2 is 0, all the way until negative 4. Let's come to when the red die is showing face 6 and the blue die is showing face 1. So 6 minus 1, 5. 6 minus 2, 4. 6 minus 3, 3. All the way until 6 minus 6, we have a 0. Now, part A of the question is saying, find the probability distribution of m. The probability distribution will be determined by the result that we are having. In our sample space, this one, we have how many results? 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. We have 36 results. And out of 36, I think the least value is minus 5. And minus 5 appears how many times? Only once. So the probability when m is minus 5, the probability of minus 5 is 1 out of 36. That is how we come up with 1 out of 36. The probability of minus 4, how many do we have? 1 and 2. Then we have 2 out of 36. How many minus 3s do we have? 1, 2, 3. 3 out of 36. All through, but let's concentrate on how many zeros do we have. And 0 will be realized when the blue die is showing the same face shown by the red die, such that 3 minus 3 is 0, 6 minus 6 0. How many zeros do you have? 1, 2, 3, 4, 5, 6. We have 6 out of 36, the probability of achieving 0. The highest value is 5, here it is, and how many 5s do you have? 1 out of 36. So just that is how we can simply answer the first part A of that question. Let us go to part B. Write down expected value of m, EM. EM, as we know from the previous example, is sigma m multiplied by the probability of the m itself. And how do we go about it? We must create now another row that is going to capture m multiplied by the probability of m. And this is the row. So when m is negative 5 times its probability, minus 5 times 1 is minus 5 out of 36. Minus 4 times 2 is minus 8. Minus 3 times 3, minus 9. Minus 8, minus 5. Of course, 0 times 6 is 0. 1 times 5 is 5 out of 36, all the way until we have 5 out of 36. Now, for the sigma, we have to add everything along that row, because we want to capture the sum of. Even before we try to put them together, you can already see there is a negative 5 out of 36, which cancels with positive 5 out of 36. Negative 8 cancels with positive 8. Negative 9 out of 36 should cancel with positive 9 out of 36. And even this should cancel with that. And the last one, minus 5 out of 36, should cancel with 5 out of 30. So basically, the sigma m pm is ideally 0. And that is now the answer to part B of that question. Let's talk about part C, the variance of m, or the var m. The variance of m, as we have been explained before, the variance of m is expected value of m squared minus the em itself squared. So, and of course we have been calculated em up there. And of course we know that our em is 0. Em is 0. So what we need to take care of is the em squared. And what is the em squared? Look at this. Expected value of m squared is the sigma of m squared multiplied by the probability of m. What does that mean? We have to keep squaring the value of m. We have to keep squaring the value of m. And in this case, when m is minus 5, m squared becomes 25. 25 times the probability of m, it gives us 25 out of 36. When m is negative 4 squared is 16. 16 times 2 is 32 out of 36. When m is minus 3 squared is 9, and 9 times 3 out of 36 becomes 27 out of 36. And when m is now minus 2 squared is 4. 4 times 4 out of 36 gives us 16 out of 36. And finally, when we have m being negative 1 squared becomes 1. 1 times 5 is 5 out of 36. And of course, if you continue, when m is now 1 squared is 1, 1 times 5 is 5 out of 36, which is a repeat of this. And this is a repeat of this. And this 9 times 3, 27 out of 36 is a repeat of this. And this has been repeated here. And this is again a repeat of this, because 5 squared is 25 times 1, which is a repeat of this. So I've just multiplied what I had until there times 2, instead of now filling the board with the same thing. And this gives me 25 plus 32, that is 57. 57 plus 27 plus 16 plus 5, that is 105, times 2, that is 210. So we have 210 out of 36. And we can simplify this further by first of all dividing by 205 out of 18, and we can go further to divide by 3, and it gives us 35 out of 36. At this particular point, we should have gone ahead and divided everything by 6, which should have given us a 5 out of 36, which is the same thing that is shown here. So this is the var of m. All right?